Okay, now let us take a 2002 problem. So it's a way beyond question, but it's a very good question. Let's see how to solve it. You have to find the locus of a center of a circle which touches these two circles externally. Let me write down the equations of the circles that are given to you. This is first circle, and the other circle is z minus z2 is equal to b. Okay, so by this what I mean is the center is z1 and the radius is a. Here the center is z2 and the radius is b. Now you have to find a circle which touches both of them externally. Okay, now let us see by graphically, by pictorially, what do you mean by this? If this is one circle, this is, let's say, other circle, and this is your z1 and this is your z2. Now the third circle that you have to draw is touching these two circles like this. Let's say this is the circle. So this has to be the case. And if I take the center of the circle which I have to find, that is the locus of the center, be z0 and the radius as r0. So let's see when you touch externally what the cases can be. Let me draw first of all. Okay, let the radius be r0. Already given that the radius of this circle is a, the radius of the second circle is b. So this whole length, now let's see what it will be. We know, you know that the center is z1, here the center is z0. So if I can write z0 minus z1, what it will be? This length, let's suppose this is a, this is b, this point that I'm talking of, and this point is o. So this will be OA length z0 minus z1, which is nothing but what? A plus r0. If I talk about length OB, what it will be? z0 minus z2 is equal to, this will be b plus r0. Alright, so this is my third equation and this is my equation fourth. And if I subtract these two, let's see, subtract, because I need to find equation only in z0. Why I am subtracting it? That's a very important point to understand, that why I am subtracting these two equations. I have taken two variables now, z0 and r0, and I need to find the locus of z0 only and not r0. So I have to subtract r0 from my main equation that I'll get. So that could be done very easily if I subtract these two equations. So this will become z0 minus z1 minus z0 minus z2 is equal to a minus b. Okay. And as we do in locus problems, what we do, we take the point which we have to find the locus. I have taken z0, try to find out the equation in terms of that z0, and finally replace z0 by z. Okay, replacing z0 by z. So that will become z minus z1 minus z minus z2 is equal to a minus b. And now if you closely look at this equation, this is nothing but equation of what? Hyperbola. So this is an equation of hyperbola. So again, this was a geometry problem. Why geometry problem? Because if you do not know that this equation is equation of hyperbola, okay, then you will not be able to solve this question. Because if you go on solving this equation now algebraically, it's going to be a huge question for you. You will take around 10 minutes of your time, and 10 minutes is devastating in an exam if you are devoting 10 minutes to a single problem. Okay, so you should remember these kind of equations, and for you I can write some of them here only. Circle, we have already done that, z minus a is equal to b. Okay, this is the equation of circle. This is basically z minus z1. If you talk about, if we write plus sign, z minus z2 is equal to a. This is equation of ellipse. Okay, or if I write z minus z1 minus z minus z2 is equal to a, this could be a equation of hyperbola. Okay, now there are constraints on a as well. Every time this equation will not be equation of an ellipse or a hyperbola. There are some constraints on a that you will have to look out for. Okay, I've just written out the formulas which are there so that you can know what are the formulas. Just look into any book that you have in your hand or at your home, you will get the formulas for this. Okay.